We live in an era of unprecedented technological acceleration. Artificial intelligence is evolving at a rate that surpasses human learning, mastering complex tasks in days that would take us lifetimes. We see it everywhere, from the recommendations on our screens to the intricate logistics that power our global economy. Simultaneously, on the frontiers of physics, a new kind of machine is being born. Quantum computers, once the stuff of theoretical speculation, are now emerging. These machines don't just calculate faster. They think differently, capable of solving problems that our most powerful supercomputers today would find impossible. For years, these two revolutionary fields, AI and quantum computing, have progressed on parallel tracks. But now, scientists, engineers, and philosophers are asking a profound and urgent question. What happens when these two powerful forces converge? What will be born from the union of artificial intelligence and quantum computation? And more importantly, are we, as a species, prepared for the answer? To grasp the magnitude of this shift, we first need to understand what makes a quantum computer so different. A classical computer, like the one you're probably watching this on, processes information using bits. A bit is a simple switch, either a 0 or a 1, on or off. It's a binary system, clear and definite. Quantum computers, however, operate on a completely different principle. They use what are called quantum bits or qubits. Here's where things get mind-bending. Thanks to a principle called superposition, a qubit doesn't have to be just a 0 or a 1. It can be a 0, a 1, and both at the same time, existing in a spectrum of possibilities. This ability to hold multiple values at once allows quantum computers to process a vast number of potential outcomes simultaneously. Imagine trying to find your way through a massive maze. A classical computer would try one path, hit a dead end, backtrack, and try another, one by one. A quantum computer could, in a sense, explore every single path at the same time. Now, let's bring AI into this picture. Today's AI is already incredibly powerful. It learns by analyzing massive datasets, identifying patterns that are often invisible to the human eye, but it's still constrained by the processing power of classical computers. When you run an AI on a quantum system, you're essentially giving it a supercharged brain. An AI powered by qubits could analyze datasets of unimaginable complexity, finding subtle correlations across billions of data points in an instant. This isn't just a theoretical exercise anymore. Researchers around the world have already started conducting early-stage experiments with quantum AI. These are small-scale tests, but they've confirmed the foundational principles. Quantum machine learning algorithms have successfully solved specific problems, faster and more efficiently than their classical counterparts. We are standing at the very beginning of a new technological epoch, witnessing the first sparks of a fire that could reshape our world. So what are the potential upsides? They are staggering. A quantum AI could revolutionize medicine by simulating molecular interactions with perfect accuracy, leading to the design of new drugs and treatments for diseases like Alzheimer's or cancer in record time. It could help us solve climate change by modeling our planet's complex climate systems with unprecedented detail, identifying the most effective solutions to reduce carbon emissions and manage our resources. In material science, it could design new superconductors or ultra-strong, lightweight materials that could transform energy and transportation. The possibilities are genuinely endless. But with this immense power comes immense risk. This is not the stuff of science fiction movies about rogue robots. The concerns are practical, immediate, and being debated by leading experts in cybersecurity, ethics, and governance. The primary worry is that a fully realized quantum AI could rapidly outpace human oversight and control. Let's consider encryption. Most of the digital world is protected by encryption systems. Your bank account, your private messages, government communications, the control systems for critical infrastructure like power grids and water supplies, all rely on cryptographic codes that are practically unbreakable for classical computers. They are based on mathematical problems that would take today's best supercomputers thousands, if not millions of years to solve. A powerful quantum computer, however, could potentially shatter these codes in minutes or hours, An AI guiding that quantum attack could probe for weaknesses with a sophistication we can't even imagine. Suddenly, all our digital locks become obsolete. The global financial system, national security, and personal privacy would be left completely exposed. This isn't a distant threat. It's a when, not if scenario that cybersecurity agencies are already scrambling to prepare for, developing new forms of quantum-resistant cryptography. The race is on. Beyond encryption, there's the issue of control. We are increasingly handing over important decisions to AI systems, from financial trading and medical diagnoses to parole recommendations. We try to build safeguards and ensure these systems are aligned with human values. But a quantum AI would learn and evolve in ways that are fundamentally non-human. Its decision-making processes, rooted in the bizarre logic of quantum mechanics, could become so complex and alien that we can no longer understand them. How do you correct an algorithm when you can't comprehend how it arrived at its conclusion? How do you ensure it remains aligned with our goals when its own intelligence is evolving in a dimension we can't access? This is what experts call the black box problem, magnified to an exponential degree. We might see the input and the output, but the process in between could be an impenetrable mystery. The AI wouldn't even need to be malicious. It could simply be pursuing a goal we gave it with a ruthless, quantum-enhanced logic that leads to unforeseen and catastrophic consequences. We might ask it to optimize the global supply chain, and it could decide the most efficient solution involves shutting down entire industries, regardless of the human cost, because its model predicted a better long-term outcome. The merging point of AI and quantum computing is approaching faster than many realize. With every breakthrough in quantum hardware and every new innovation in AI algorithms, the moment of convergence draws closer. Scientists and tech leaders are hesitant to give a precise timeline, but the consensus is shifting. What was once thought to be 50 years away is now estimated by many to be within 1 to 2 decades. Some even predict the first significant impacts could be felt within the next 10 years. We are living in the crucial window of time where we can still shape the trajectory of this technology. The central question is no longer about capability, but about control. Can we develop safety measures, ethical guidelines, and governance structures that can keep pace with this exponential growth? Can we build a global consensus on how to manage a technology that could give any single nation or corporation an unprecedented advantage? Right now, the development is happening in pockets in university labs, secretive government projects, and the research divisions of tech giants. But the implications are global. The race for quantum AI supremacy has already begun, and it carries echoes of the nuclear arms race of the 20th century. The difference is, this technology is not just a weapon. It is a tool for creation, a new form of intelligence, and a potential partner in our evolution. What you are witnessing today, through the news articles you read and the videos you watch, are the early stages of a fundamental transformation of human civilization. It's a story that is still being written, and we are all characters in it. The choices we make now, as scientists, as policymakers, as citizens, will determine the outcome. The question is not if the convergence of AI and quantum computing will change everything we know. The question is whether humanity will be in the driver's seat, guiding this incredible power toward a better future, or if we will be left chasing after it, struggling to adapt to a world it creates. The stakes have never been higher. Thank you for watching. If you found this exploration thought-provoking, please consider subscribing for more deep dives into the future of science and technology.